Hello and welcome back to this video series for higher chemistry calculations. Today we are going to look at percentage yield calculations. So we know that chemical reactions very rarely have 100% yield of product, so we can use this calculation to work out how much product is actually being produced. Now our percentage yield and atom economy calculations are carried out to see if a reaction that we are doing is the suitable process. Reactions with a high percentage yield and low atom economy are inefficient and wasteful, and so they're not undertaken. Quite often you will see these two types of calculations paired with one another in the exam. Our formula to work out percentage yield is simply our percentage yield equals our actual mass, which is usually given to you in the question, divided by the theoretical mass, which you need to work out, that's your calculation part, times 100, and it will be whatever percent. Okay, let's have a look at past paper style questions on percentage yield. In a preparation, 3.2 grams of propanol is obtained from 3.9 grams of propan-1-ol. Can we calculate the percentage yield for the reaction? So we have here our balanced equation. First things first, we can clearly see that it's a 1 mole to 1 mole reaction. Okay, we have information about our propan-1-ol. We know that it's 3.9 grams of propan-1-ol is used in a reaction, so we can work out the number of moles by doing mass divided by GFM. So our 3.9 moles, and you will have to work out the GFM based on the formula that we've got here for propanol. So 3.9 divided by 60 will give you 0.065 moles. Now, since it was a nice 1-to-1 mole ratio, we can just pop 0.065 moles up here, and it will of course be the exact same on this side, 0.065 moles of propanol that has been made. Okay, now our percentage yield calculation requires two bits. We've got our actual yield over our theoretical yield times 100. Okay, so our actual yield comes from the question. It told us 3.2 grams of propanol was created. Okay, we need to work out what our theoretical yield would be. This is where you use this number of moles. Okay, so for our theoretical yield, our theo yield, we're going to do mass equals number of moles times GFM. We know the number of moles, so 0.065 moles, and we're going to times that by our gram formula mass. So you need to do the working for your gram formula mass of your propanol. So C2H5CHO sorry guys, that's off camera there, and that will give you 58 grams. So we're then doing 0.065 times 58, and that gives us a theoretical yield of 3.77 grams. Okay, so if we go back here, our actual yield from the question says in a preparation 3.2 grams of propanol. Okay, so 3.2 is our actual yield from the question. Theoretically we should get 3.77 based on the mass of propan-1-ol that was used. So we're going to do 3.2 divided by 3.77 times 100, and you will get a final yield of 84.880, so 84.9% for your yield there for that calculation. let's move on and look at another example, something that looks a bit different this time. Okay, so here we have a different style of question. Okay, this time you are given your equation as the file structure formula, and it says in a preparation 20.4 grams of 1,2-dibromo propane is obtained from 5.2 grams of propane. Calculate the percentage yield. So what to do right now is, if you pause this video, have a go at this calculation, and then once you've got a final answer, come back and we can check it against what I'm going to do in the video. Okay, so pause, have a go, and I'll see you in a few minutes. Okay, welcome back. Let us go through this together, work our way through it, and see if it matches your answers. So, in a preparation, 20.4 grams of 1,2-dibromo propane is obtained from 5.2 grams propane. Calculate the percentage yield. So we've got propane, CH6, gives us our dibromo propane. Okay, it is a 1 mole to 1 mole ratio. That is our actual yield, that's how much we're saying we've obtained, and we're going to use our 5.2 grams of our propane, our starting material, to work out the number of moles for the mole ratio. So number of moles equals mass divided by gram formula mass. So 5.2 divided by our GFM of propane, which is 42. .2 divided by 42 gives you 0.124 moles. So our actual mole ratio is 0.24 moles. It's a 1-to-1, so we're going to be creating 0.24 moles of our dibromo propane as well. Okay, to work out our theoretical yield, we are going to do mass equals number of moles that were worked out there times our GFM. Our number of moles is 0.124, my apologies guys, 0.124 times our GFM, which, let's have a wee look, CH6 BR2, which is 201.8. So 0.124 times 201.8 should give you a theoretical mass of 25.0232. 25.0, we'll just leave that at. So if we come down here, we can do our percentage yield equals our actual yield divided by our theoretical yield times 100. So our actual yield from the question is 20.4 grams. Our theoretical yield is 25.0. And then we're multiplying that answer by 100, and that should give you a percentage yield of 81.6%. 81.6% for that calculation. Another way to do percentage yield calculations is by using mass ratios instead of mole ratios. So you're using the exact same formula, but instead you're not going to have to calculate the number of moles this time. Some people find this easier because it has far less steps and less maths to do, less rounding to do, so potentially less places to go wrong. So let's have a look at this question. It says, one method of preparing silicon hydride involves reacting magnesium silicide with hydrochloric acid. 15.32 grams of magnesium silicide was reacted with excess hydrochloric acid. 2.56 grams of silicon hydride was produced. They've given you a balanced equation and the gram formula mass for magnesium silicide and for silicon hydride. They're saying calculate the percentage yield of silicon hydride. So these are the two that we're interested in. So the first thing I'm going to do is I'm just going to write that out here again. It is a 1 mole to 1 mole ratio. Okay, I know that the mass of 1 mole is a gram per unit of mass, so here I have 76.7 grams of magnesium silicide, which produced 32.1 grams of silicon hydride. However, I'm not putting in 76.7 grams, I'm only putting in 15.32 grams. So what I'm going to do here is I'm going to do 15.32 times 32.1 divided by 76.7. So this time I'm doing a ratios based on my masses, not my moles, and I've got 6.41 grams. This is my theoretical yield. Okay, so the calculation I've just done there, that's my theoretical yield. And just like before, I'm just going to do percentage yield equals my actual yield over my theoretical times 100. So the actual yield comes from the question. It tells us 2.56 grams. Our theoretical is what we have just calculated, 6.41. And if we multiply that by 100, we get a percentage of 39.9% for that question. Okay, so now that you have seen 2 different ways to calculate the percentage yields in higher chemistry papers, it is up to you to decide which method you're more comfortable with, whether you like the kind of, I would say maybe more traditional, maybe more familiar mole ratio method that we showed first, or whether you find the mass ratio methods better. It is entirely up to you. Both methods are completely accepted and correct. Just choose one and stick to it is what I would say. Hopefully you found this video helpful. If you have, please make sure that you subscribe to the channel and turn on notifications so that you can see when any new higher calculations videos drop. Good luck for your exam, guys.